Hello, biologists, chemists. We are starting on chapter 3. You should have a lecture outline. Here you go. There's one on Canvas. And there are little places for you to fill in. Okay, lactose is the major sugar found in milk. Ice cream, milk, butter, things that have a lot of milk products in them. Lactose intolerance is the inability to properly digest lactose. So basically, instead of lactose being broken down and absorbed into your small intestines, it is broken down by bacteria in the large intestines and produces gas and discomfort, usually in the form of kind of urgent diarrhea. So you would know if you're lactose intolerant. What does happen when you get in college is you don't eat breakfast in the morning anymore sometimes. So you'll go a whole week without milk products, and then you will flood your body with dairy on the weekends, and sometimes you will experience these effects. It doesn't necessarily mean you're lactose intolerant. You can increase your lactose uptake, and that will sometimes relieve this problem. But a lot of people do, as they get older, become more and more lactose intolerant. Not this little girl. Look how cute she is. She does not have lactose intolerance. She is loving her chocolate milk. Again, lactose intolerance can be addressed by avoiding lactose-containing foods and consuming some lactate right before you have milk products. And this is the part in the chapter where we tell you how important macromolecules are. And that is lactose is an enzyme, it's important, it breaks down dairy, and therefore you should care about this chapter. So here's also some things why you should care: muscles, how ATP gets in your body, how sugar is broken down and how sugar is made, different parts of the environment, lipids, fats, proteins, carbohydrates. That's what we're about to talk about. So let's talk about the cell. No, we're not doing the nucleus and the ribosome. I know that makes you sad. We're not doing that yet. A cell is mostly water. The rest of the cell consists mainly of carbon-based molecules. Carbon forms large, complex, and diverse molecules. Carbon is an element on the periodic table. Organic compounds are carbon-based molecules. Write that down. Carbon-based. So when we say organic compounds, or when we say organic farming, basically that's just chemicals made from carbon. Doesn't necessarily mean it's better for you. It just means chemicals made with carbon. So that's usually natural products, but it doesn't have to be. So organic means carbon. It's very confusing because it doesn't mean healthy. It just means carbon. Carbon is a very versatile molecule. Basically, we are alive. Life on Earth happens because carbon is awesome. I know I said that in the last chapter, that it's because water was awesome, but it's also because carbon is awesome. So carbon can share. Remember the sharing that is not necessarily so equal sharing. So it is 4 covalent bonds, not ionic. They're sharing unequally, so there's going to be charges. Because carbon can use one or more of its bonds to attach to another carbon. Now, if it does attach to another carbon, that's usually equal sharing. It is possible to construct an endless variety of what's called carbon skeletons. We're getting close to Halloween, so imagine a carbon skeleton just like skeleton. And these vary in size and branching. Here's some examples of some pretty carbon molecules. They vary in length. They sometimes have double bonds. They're really pretty circles. You can do all kinds of things with them. We'll try and play with some in class. The carbon atoms of organic compounds can also bond with other elements like hydrogen, oxygen, nitrogen, all kinds of things. The answer there is elements.
The carbon backbones of organic molecules may vary in length and in location of single and double bonds. Molecules may be straight or branched and may even contain rings of atoms.
There we go. One of the simplest organic compounds is methane. See a carbon with 4 hydrogens. I'll show you that in a minute. Basically, it looks like this. 1 carbon and then 4 skeletons coming off it. The simplest you can get. Methane is abundant in natural gas and is produced in swamps, and it's called swamp gas, and it's also why everybody's mad at cows right now, because cows burp methane. They also fart methane. There you go. It's a little bit. But the digestive system mostly gets it out through the burping of cows. So they eat food, it ferments in their rumen or their stomach. They have several stomachs, and it just ferments in there, and then they either belch or fart the methane out, the gas in their stomach. So they basically just spend all day eating, farting, and burping. It's pretty much a cow's day. And there's some concern about that for the environment. Okay, here's what methane looks like. It's just a carbon with 4 hydrogens. Here it is in the ball and stick method, carbon, 4 hydrogens. Here it is in the space filling method, carbon, 4 hydrogens. Larger organic compounds are the main molecules in gasoline that we burn in cars and are important fuels in your body. So it's basically a source of fuel for both cars. And carbon is important. The energy-rich part of fat molecules have a similar structure to gasoline. So this is octane, and this is dietary fat. So all carbon-based molecules. The unique properties of an organic compound depend on its carbon skeleton. So the carbon skeleton is going to be the carbon with all those hydrogens on it. And the atoms attached to how those carbons form. So what the skeleton looks like, and then what kind of clothes it has on, if you want to think about it like that.